Okay, folks, I hope that this is going to work. Yeah, I think I'm online. Ooh, this was a stress. Okay, let me see. Now I see you. Okay. Folks, I hope that this is going to work. Yeah. Okay. Sorry about this, folks. This was a technical glitch, and I had to restart everything. I hope that you were able to find me again. This was a little bit stressful for me now. Okay, but I see that you're now joining in the next in the next in a new chat. So sorry about this again. I started the stream and I misclicked and I stopped it again and I could not restart it anymore. So we're back here and I hope that more people are going to find this. Okay, here we go. I gotta calm down now, because I had now 3 minutes of excitement. Okay, so first of all, hi, hello, and welcome again. I'm glad that you're able to join me again. Microbehunter here. That's the way I usually start. The stream. Over the next hour or so, I want to put this stuff here under the microscope. These are so-called Seaballs, and I got them as a present from South Africa. A colleague of mine went to South Africa and she collected those and she brought them back and she told me, here's something that you can put under the microscope. And of course, I'm quite happy about this. I did not know what they are. I'm just going to tell you because somebody already said this. I hope they're going to be insects in there, because they look like a cocoon. No, that's not the case. This is seaweed. So basically, this is dry seaweed, and how it actually came into this round shape, it's because of the wave action, and it's kind of the waves roll it up into these balls here. So what I'm gonna do now is before we have a closer look at this, I would like to again say hi around the world, okay, from Rhode Island, okay, from the Netherlands, okay, from Finland, Germany, USA, okay, Belgium, Hungary, and Montreal, Canada, Ireland, Netherlands, UK, Philippines even, I hope to find some insects inside. And sorry, there won't be any insects in here. Okay, Northern Germany, hello from England. So, and I really hope that, let me quickly check something else, if you don't mind. I'll quickly check my own channel again, if there is still something going on in the other channel, just in the other stream. Just a second, please, because I have to check if there are still people waiting in the other stream on the other link. And this would be actually a pity because I don't want to lose any viewers. So I've got the other one over here. So what I'm gonna do is in the old link is okay. I'm going to do the following. Just a second. Okay. I quickly save this. I just posted in the description of the old video that there is actually a new link here that I'm using right now. Okay, that's fine. Because in case somebody else joins in a little bit later over the other link, then yeah. So okay, so basically, you know the convention. If you have any questions to ask, please feel free. Just give me an @Microbehunter in the chat, and I'll try to find find those comments, and then I'll try to answer them. And after approximately 1 hour, I'm going to try to answer some of your off-topic questions. Okay. So there is a question: has this happened the first time? Yes. Basically, what I've done is I started the stream. I have to click go live, right? And then when I click it again, then the broadcast is being stopped. And I accidentally clicked it twice. So I started it, and then after a second, I stopped it again. And when you stop it, then essentially, the stream stops and I cannot restart it because then I have to create a new link and a new stream in YouTube. So that's a little bit basically it was not an accident, so to say, a technical accident. Rather, it's because I messed up. Okay, that's the reason. Yeah. So, okay, so a little bit background here again. So a colleague of mine in work, where I work, visited South Africa, and she brought along these things here, and I thought the first time these are some kind of cocoons, right? And then I said, are there some insects in there? I actually also thought that there's some animals in here, but I actually said, no, don't worry. These are actually rolled up balls of seaweed. Or seagrass, and I never seen anything like that. But I would like to show you the following because I found actually in Wikipedia, over here, actually an Wikipedia article, right, about these Seaballs, and even some pictures here, right. There it says here the tightly packed balls of fibrous marine material recorded, from the seashore. They vary in size up to about 7 centimeters. I mean, it's kind of huge, right? Okay, and they found even some of the 45 centimeters across. I mean, this is really gigantic. Huh? So, and interesting, in recent years, they have been shown to contain more and more plastic, marine debris, and even microplastics. Not surprisingly, because you find microplastics these days, pretty much everywhere, right? So, and what I want to do now is the following today. I've collected. Let's go back to the desk view again. Look, there is a little bit of sand in here as well that I collected. So I'm going to also put this under the microscope, and I would like to also make again a few permanent mounts of these, of some of those. Of the seaweed as well, and then see how this works. This is not going to take us too long, I think. Another thing that I've kind of planned to do, simply as a little bit as a demonstration, something totally different. I did prepare a little bit of starch, and I would like to also try to digest a little bit of starch using some amylase, which I've basically got here, and observe this under the microscope. And then, if this doesn't basically allow us to complete the live stream, then I've got also a moldy tomato here, some mold. So there are plenty of things to look at today. Okay. There's a comment, consider changing your double-click timing on your PC. It's essentially there's this button in OBS Studio where it says start, go live, and then end broadcast. And I, for whatever reason, clicked it twice because I thought that the first time it didn't record. Yeah. So for this reason, yeah. So first things first, let's do the following over here. This is my. This is bad. I wanted to show this to you under my stereo microscope, and now somehow I've got another technical issue because it doesn't show the stereo microscope. Otherwise, I'm just not a. Pooh, that's again a little bit of sad thing. Okay. Here we're back. I'm happy. I was stressed again. Okay, so that is basically under the stereo microscope. So you see a lot of it's not only seaweed but lots of other stuff. I don't know even what that is. Yeah, but you can see that pretty much a lot of things that can be found in the ocean kind of got wrapped up in this ball of seaweed. I think I've even seen something that looks like pine, some needles of some leaves of coniferous trees, even, or something like that. Yeah, so it's kind of it's pretty compact. Yeah? So it's not hollow. I thought, as I mentioned before, there was kind of maybe some animals in there who made a cocoon, but it's actually rolled up because of the wave action. Yeah, we can zoom in a little bit with the So, demonstration effect strikes here. It's always Murphy's law. If something can go wrong, it will go wrong. It's always like this, yeah. I mean, as a matter of fact, I struggled a little bit because I had a problem just a few minutes before I started the stream. I had a problem with one of my cameras because I've got, I don't know, 6 USB cameras connected to the computer. Then sometimes the USB connection isn't working. Yeah, so you see that it's kind of actually quite quite interesting here. Well, interesting. I mean, I think it's fascinating to see how a wave action is able to compact everything here. But of course, I'd like to put this a little bit more under the microscope, under the compound microscope as well. So what we have to do is we have to prepare some permanent slides. Yeah. Those Seaballs probably have a nice smell. I didn't smell them yet. Why not? Why not try that? Let me see. Actually, they smell pretty neutral. Yeah, they smell pretty. Actually, they don't smell. No, they don't even smell. They don't even. No, they smell like nothing. Not even like sea or salt or anything. Yeah, so it's kind of interesting. Yeah, so yeah. So and what I've done here is just for your info. I basically knocked a little bit on the Seaballs, and out came a little bit of sand. And yeah, which I just wanted to put under the microscope. And I also made a so-called a dry mounted slide, which I need to explain a little bit how I made that. So let's make this a little bit bigger. Okay, look, yeah, so basically no mounting medium. So the black ring that you see here is a 3D printed ring, about 1 millimeter high. And I glued it on the slide, and then I put some of this material yeah, in here, and I put a round cover glass on top and also glued it on here, right? So this is simply something that I would like to try, and then by knocking around you can always see it a little bit differently. Yeah, so that's, by the way, those slides, why I'm using, it's not a sponsored video in that sense, because, yeah, but the company Globe Scientific, they sent me a whole box of, yeah, without me ordering it and without any preconditions, it just sent me a box of microscopy material. And yeah, I think it's quite nice from them. I just would like to just say thank you to them as well this way by just using these slides here. So let's do the following. Let's put this under the microscope. And here it is. Let's remove the arrow again. Yeah, for those of you who are new, the reason why it's so colorful is because of the polarization I have of the DIC. That's a specific technique. But we can, of course, always also switch off everything here, and this is how it looks like. And there are a couple of nice sand grains here, yeah, and yeah, and we're already at the edge, and over here these things here, that is this basically that's the seaweed, and it's completely dry. But when we go in, then yeah, we can see it's still fairly dark, and my hope is a little bit is that by putting it into water, maybe we're able to see a little bit more clarity here, right? So that is one of the one of those tiny little seaweed leaves here, yeah. Yeah. So yeah, there is a comment from Alexander. You need to get more partnerships like this. Ask people. You will be surprised of the response. Yes, maybe, probably. And indeed, in my other YouTube channel that I have, it's called Microbehunter Microscopy. Indeed, I'm also doing some microscope reviews that company sent me. But I have to tell you a little bit honestly, I don't know. I feel a little bit. I'm always very grateful when people send me things. But yeah, I feel a little bit uneasy sometimes asking for things. Yeah, I don't know. Yeah. I know one shouldn't feel uneasy about it, yeah, but still, yeah. But I would like to show you the following, because I made a small video as well just before, because I did find something, not in this one specifically here, but yeah, you see a lot of sand grains and so on, yeah. Could there be anything in these balls that might still be alive? Well, let's put it this way. This is a natural product, so to say, so I'm quite sure maybe there's some kind of cysts in there or whatever, but the question is really, I mean, once things have dried up, living things don't, yeah, bacteria definitely, right, yeah, but one would have to kind of reactivate those again, yeah. So, but I would like to show you quickly the video here that I made just a few hours ago, and no, that's another video I wanted to show you. Yeah. So that's the video that I made, okay? And yeah, And I just because I saw something which was quite nice here. Again, this is a little bit this is in polarized light, and it's actually I do need the arrow right now. Yeah, it's actually this thing here that and this over here that's actually quite remarkable. I'm gonna zoom in later on a little bit more. It's again these things here are again the seaweed, lots of sand particles. But this here, I don't know if any one of you actually knows what this could be. I'm going up now with the magnification, right? Something very, very typical. The colors here that you see is because of the polarized light. Yeah. So yeah, I'm turning up. But do you actually notice that there are these rings here, right? Yeah, these are yes. Yeah, Paul got it. Yeah, most likely, or it could be. It says here either a fish scale, either that. Yeah, but or it could be also the how do you say rings like this you also sometimes see in seashells, right? And I don't know exactly if it's going to be a very thin seashell because seashells also have these so-called annular rings, a little bit like tree rings, but also fish scales have those. So yeah. So this is quite fascinating as well that I was able to find this. Yeah. So what I would have to do is I would have to actually, in order to check if it is a part of a shell or fish scale, I'd probably have to add a little bit of acid here. And if the acid dissolves it, then it's calcium carbonate. Then it was a shell. Yeah. So that is that's the thing. Chitin from a seashell. Well. Shells actually from mollusks are actually made of calcium carbonate. Yeah? So this one is now in phase contrast. Yeah, and it does allow light to go through. So I'm not quite sure if this is actually calcium carbonate seashell. It could indeed be probably a fish scale. Yeah? So this is would be kind of something that one could try to find out. Yeah, but you see, there's lots of other stuff in here as well that maybe also, as mentioned before, microplastic or so or whatever, right? So this is so what I would like to do now is where's the scope here? That is basically what we had a look before, right? Over here, this is in bright field. Okay, so it's not quite as colorful here. But what I would like to do now is I would like to simply make a wet mount, and I would like to simply add a little bit of water here first. The problem that we have here is that it's a fairly thick specimen with all of the sand, but that's okay. We're just gonna give it a try in any case. So the desk here, and here we are again. And I'm just going to try to make a little wet mount. Yeah, I'm going to be using the cheaper slides here now. Yeah, and I need some water, and maybe we're able to. Yeah, I also soaked some of them already, some of the seaweed already here a little bit in water. So let's take some of them here as well. And a little bit of sand wouldn't hurt. Let's. Okay. And the cover glass goes, of course, on top. Here they are. And this is actually a little bit a pretty thick specimen, as you can see. Yeah, but I guess it's okay. Yeah, I might want to add a little bit more water. Okay, then let's have a look now if there is a difference. I have to. So that's that's still the dry one, and here this one is the one, which contains the water. And see if there's something, And the nice thing about adding water is because there's the difference in refractive index is not quite as high, and therefore the sand grains and all these things look a little bit brighter, right? And then now you can also see that, also the plant material here is also quite a bit brighter. So, and 40 times, So that's still, maybe slightly lower. And what one could then do is, of course, yeah, look, try to hope to find something, yeah, of interest. What is this round thing here? I have no idea. What's this round thing here? I don't know. Huh. That's interesting. Yeah. No idea. Let's put DIC in again. Yep. So, and yeah, here we go. So this was basically, I don't know, at least maybe the first time that anyone put these Seaballs under the microscope. I don't know. Yeah, baby clam could be, right? I don't know. Yeah, yeah, this could be. Yeah. So that's usually some of the things that I like doing. Is I simply like to collect some specimens and simply put it under the microscope and yeah. In many cases, it's not, how do you say, in many cases, especially when you look at dry specimens, obviously you do not see a lot of movement going on. But it's simply, for me, it's an interesting extension of my senses to simply put things under the microscope. Yeah. So, is there, I think there might be a chance that those Seaballs might contain some microplastics. Or bioplastics. Well, microplastics, I'm quite sure that they do, because you find the microplastics generally a lot, pretty much everywhere these days. Yeah? But in order to actually identify them, you'd probably have to do some specific extraction or staining. Yeah, there was a little heart somewhere, somebody said. Yeah. Yeah, so that's a little bit simply something I would like to wanted to share with you. So what I'm going to do now is I would like to also a little bit experimentally. We now see that those how do you say those seaweeds, they look much brighter now than before, because they're now surrounded by water, right? Because this has to do with the mounting medium, and basically, if there's not so much difference in the refractive index of the specimen to the mounting medium, then it appears to be a little bit more clear and transparent. And what I would like to do now is I would like to simply mount some of these dry things here in... No, that's the wrong one. Yeah, I would like to mount this here on a slide. And I would like to use, not a water-based mounting medium, but I would like to use U-Pearl again. This is here because U-Pearl contains a solvent, and I would like to simply try how well this works, and it's a little bit my hope, that the mounting medium will actually also clear the seaweed a little bit. So I just put this here now on the side. And maybe I'm going to take another one. I, of course, could take this material also directly of the Seaballs, of course. It's also a possibility, but I already had them here, in a beaker, and for this reason. So let's give it a try. Here goes the mounting medium. Then I'll try to place this in the mounting medium. It's dry, of course. And next thing that I have to do is I want to, let's see. I think actually it's quite nicely submerged, but just to be on the safe side, I'll add another drop on top. And on top of this, a cover glass. Usually what I do is when I make permanent mounts, I simply, because I don't know, in some cases I simply don't know which mounting medium actually works best. I simply try, I make several permanent mounts using different mounting media, and then simply, go for the one that works best. And so it's a trial and error principle. Yeah. So let's see if this is reasonably flat. Also, I mean, I'm doing this obviously now live, and you see that it's probably there are some sand grains in here. That's why it's too thick. I normally would probably after the live stream, when I have some time, take a little bit more time in doing that and remove the sand grains and all these things to make a proper slide. But for right now, for demonstration purposes, I think it's going to be fine. Yeah. So let's do the following again. I'm removing the scope view. I'm removing again the thing here. And this is now the one with the U-Pearl, and let's have a look here. And what we have to do as well is we have to wait maybe a little bit until next week or so to see if the mounting medium actually started to clear the specimen. I mean, this mounting medium actually works quite well for insects because it does actually brighten and clear insects, the exoskeleton of insects. But let's see if this also works for plant materials. And we see that this one over here is starting to slowly become more and more transparent as it absorbs the mounting medium. One always has to be a little bit careful because the mounting medium is not dry, and if you use very high magnifications, then of course this can be a little bit risky because you might get some of the mounting medium on your objective. Okay. So yeah, occasionally. Yeah, I've read that Nile red stain is used to look at microplastics with purple light. So basically, yes, I've also heard about that. Nile red will stain microplastics, and when you use UV light or near UV light, then it will start to shine and fluorescent. And this is how you can actually make microplastics quite well visible. So I don't have a UV microscope, but maybe it's possible also to use UV flashlights. I don't know, but that would certainly be something to try out. So, so that's, yeah. Let's go all the way down with the magnification again here. And let's flip out the, so that's with low power. Yeah, it's you see it's kind of too dark. Yeah. So what I'm going to do is I'm going to simply put the slide to the side, and we're going to have a look at it then again next week to see how well actually this mounting medium actually works. If there has been some kind of a clearing of the seaweed. Clearing means basically that it becomes more transparent. So I'm going to check again if there are any comments or so. Let me just give me another check here. Live streaming. Okay, just a second. I'm going to check quickly. Yeah, there are 82 people watching, so I'm happy that that people have found the stream again. Yeah, so that's good. Yeah. Could you get a seawater sample or ask somebody local to send you some? The thing is, in principle, I don't. Somebody would have to send it to me. I was just thinking if marine salt, if you were to dissolve marine salt, if there's anything interesting to find in there, that would be something to actually try out. Generally, if you use just the water from a pond or from the ocean and so on, without actually having filtered it, then usually you do not see a lot. You won't find a lot of things because the concentration of particles is not high. But sand actually is a different case. Yeah? But often, if you put water under the microscope directly, then you're often not able to see not a lot because there is simply not enough suspended material in it. However, having said that, and actually this was actually something that I've done before already, because a couple of years ago I was in northern Germany. Basically there were, and over here, this is basically some sand and some seawater from northern Germany, Wattenmeer. It's basically they have a very long, long big beaches, and the tides are very far-reaching. So I took a sample along, and just recently I still found a couple of diatoms in there that are still alive. Yeah, so I'm quite happy about that. Yeah. So good. Next thing that I wanted to do is to just for the fun of it, somebody sent me, and I think it was quite nice, a video. So it's a little bit. I'm changing topics a little bit right now. We can always return to those Seaballs later on if we want to have a look more. Yeah. I would like to just show you I got the permission to actually share it with you, and I'm quite happy about that. There is some some information here. So basically the video was sent to me by Dave Lewis. Thank you very much. Right, equipment was a Fujifilm X-A5 camera mounted on the bellows frame using a Leitz 2.5. Objective, and it's a time-lapse video of a developing frog, and I think it's pretty cool. So and thank you. It was sent to me so that I can share it. So I thought maybe I'm just going to show this to you. Let me go back here again here. So it says frog spawn recorded on the 24th of February, 4-day sequence. So this is something that's been recorded over the course of 4 days. This is quite something, okay? So we're starting off what appears to be the egg, the fertilized egg, and then it's a time lapse on how the tadpole starts to form. Yeah. I mean, I consider it absolutely interesting and fascinating that you're able to stabilize everything so much, to take a recording, over 4 days. Yeah. So you can actually see how the tadpole is developing here. Yeah. This is quite something here. Yeah. So a developing frog. Yeah, and then later on it will actually hatch, and it will escape. Yeah. And gone it is. Okay, and it starts again. Yeah. So this is so I would like to say thank you very much for sharing this video. It's also I like it because it's quite informative here. Yeah, it shows quite nicely the developing of an embryo here. Yeah. So it's I think pretty cool. Yeah. So this is I have to tell you I wouldn't know how to be able to maybe in a petri dish or something like this, or maybe you have to take a picture every couple of seconds. I don't know. Huh? But over 4 days you have to standardize all of the lighting and everything. Yeah. So it's definitely taken because you see all of the white dots. That's probably the dust on top of the petri dish. Yeah. So you have to put a lid on top of it so that essentially the water does not evaporate over the 4 days. Yeah. So again, thank you very much. I think it was really a nice contribution here. Yeah. So the white section is a skeleton, gets folded inside. You've joined in here as well. Okay. Again, thank you to Dave Lewis for sharing this video. It's pretty cool. Yeah. Maybe you can can I ask you a little bit, Dave? He's he's in the chat right now. How did you actually film it? Did you actually take a picture, a photograph every couple of seconds, or how did you actually do that? Or was it actually recorded into a computer? I would be interested. Okay. How you actually have done that, because a 4-day time lapse is quite quite a long time. So this is really nice, and honestly, what I'm going to probably do, this is why I was so happy about this, is because I'm a teacher, and when we talk about embryonic development and so on in school, then this is actually a nice video that one can actually share. Yeah. Or show to the school. Yeah? Vertical slide, 60 seconds interval. Vertical slide. Can you please explain a little bit what you mean with a vertical slide? Did you actually place the slide vertically? And then every minute a picture. Okay. So this is really cool. Thank you again, and for sharing this. Yeah? So. what I would like to do now is let's go back to the desk view. I always check a little bit the thing here. Yeah, you can actually see here that you can actually see here that if you bounce it around like this, Dave just responded. I make mini and micro aquariums. Okay. Yeah, that's that's interesting. So I suppose that because you said that you used some kind of a bellows frame, that you probably took the video of the developing frog spawn maybe horizontally like this, and so basically it's like an extreme macro, I suppose. Yeah. Okay. Yeah, if you bounce it around like this, then you can actually see that there's stuff coming out here. Yeah. I have to see if the stereo works again, because here we go. Let's have a look. Let's have a look at this here. Maybe we're able to find something. There's by the way, there's another little tiny project that I have. So that's how it looks like here. Notice the following. And maybe the video right here on top, right? You see that I've got over here this kind of a plastic. So there's a lamp from the bottom, right? Which I'm not using right now. And you can put this plastic. You can put this plastic thing in here. If you actually notice, then the plastic surface here is not entire. It's not completely black. So what I'm doing right now is still planning out a little bit and actually buying this completely. There's this paint called Vanta Black, which apparently makes completely black surfaces, and that would be actually something that I'm also planning to do, is to actually make an inset which is painted with this Vanta Black, which is completely black. Yeah? So this is currently it looks a little bit dark gray. So that's another thing. So let's have a look here. So no more questions, which is fine. Okay, but please feel free. So, but all of the sand I'm going to collect. So there's a question here that I also wanted to know. How did you fix the frog egg so it won't move for 4 days? Especially if you have it in some kind of a vertical slide maybe, and if you, what I assume, basically the camera was filming this horizontally. How did you actually make sure that the frog egg did not actually sink down? Maybe it was supported somehow somewhere. It would be kind of would be interesting to So how come it did not fall down, or maybe it was squeezed in between two glass two glass surfaces? I don't know. So here, desk view again. So what's next? So I'm going to there's another comment here. Beware that Vanta Black is very sensitive to touch, and if you put the varnish, it's pointless. It gets gloss again. Just use regular black water paint. Okay. The gall sac supports the egg. Narrow glass. Okay. Less than 1.5 millimeters. Okay, thank you for this comment. So Dave just responded that essentially there's this the gel sac, There's a gel layer around it, and that supports the egg. And okay. And I suppose it's squeezed in between the two glass plates. Yeah. So yes, what did I want to do now? Yes, I just wanted to show you something else now. Something that I've been also. This is also some demonstrations that I'm sometimes doing with for students. But what I've got here somewhere where I've got some starch solution. So I'm basically changing topics now. Okay, I'd like to show you something. This is starch. Okay, and this is I think cornstarch or potato starch, and I added a little bit of starch and I boiled it so that it becomes a little bit clear, but it's not thick enough to be solid, right? And what I would like to do now is I want to show you how enzymes break down the starch. Okay, and you can actually see this under the microscope. And yeah, normally one would use the saliva, but it doesn't contain enough enzymes. And therefore, I've organized myself, yeah, a little bit of, look at this here. This is dishwashing powder. So basically for a dishwasher. That's it. Normally you want to use some tabs or so, but I've just also got the powdered form. And what I would like to do is the following. This is our source of enzyme because the dishwashing powder contains amylase, which breaks down the starch. And we can observe the starch digestion by mixing it with iodine. So basically, when we add this amylase to the labeled starch, then you can actually see the color disappear. So what I'm going to just show you what I'm doing is I'm just add a little bit of water in here and some of this dishwashing powder, and we're going to give it a minute or so to dissolve. Okay. There are not only enzymes in there, you're going to see that later on also quite a few bubbles appear of oxygen because it also contains hydrogen peroxide or whatever, something that generates this oxygen, right? But the next thing, so that's basically our source of enzyme. And the next thing that I would like to do is I would like to take a slide, and I'm going to now mix some of this starch solution with some iodine on the slide here. Maybe make it bigger again. Okay. And you know that when you mix iodine and starch, then it will turn completely black. This here is kind of like a brownish orange solution. And when adding a little bit of starch solution here, then you know what? Never tried that before. Let me do the following. Maybe it makes more sense to. Let me try that. Let's try to do that under the stereo microscope. Maybe I don't know if you're able to see. Yeah. Okay. Yeah. You see the reflection of the ring light. Okay, so that's the iodine. Yeah, and now I'm going to add the starch. Just a second. You probably can see that how that it immediately turns black, right? And that's a classic. That's the classic. How do you say, starch reaction? And it starts. Things that you see here, those black things. Yeah, that's basically the starch. Okay. So yeah, you see that the starch has been. So I'm going to remove some of this because I don't need that much. Okay, so I'm going to put this, and I'm also going to now remove any excess iodine as well. And maybe I just want to wash it a little bit as well because I don't like to have any concentrated iodine here. Okay. So any excess iodine, I'm going to remove. It's a little bit takes patience because the microscope is. I have to stretch out my hand a little bit here. So let's remove a little bit more of this. So here we go. So this is now the stained. That's now the stained starch. Okay, and what I'm going to do now is the following. I'm going to prepare a cover glass, and the cover glass goes directly on top, and then I'm going to switch microscopes. Okay, I'm going to then switch microscopes. So the point of the iodine is simply to make the starch visible. That's it. Yeah? So let's put. This is the cover glass that I put on top. Yeah, you get the idea. And I'm going to now switch microscopes. Where is the So let's put the filter away. So, and this is how the starch grains look like, and you see that some of them are pretty black and others are dark blue when they have not stained quite as much. And what I would like to do now is, there is not a lot of water in here, but I'm going to now add some of this prepared dishwashing solution. Okay, so let's see how we're doing here. Okay. This dishwashing solution is actually not soap. It contains a whole range of different enzymes as well, including amylase. And amylase is there to digest starch. So essentially what I would like to show you, and I hope there's not going to be again yet another demonstration effect, is that when I add this dishwashing solution to the stained starch grains, that the stain should disappear. So they should turn bright, because the amylase digests the starch. Yeah. So there is a question: what stereo microscope do you use for streaming in the internet? It's a Euromex Nexius Zoom Evo. It's called. It's a Euromex Nexius Zoom Evo, and I've got an HDMI camera connected to the microscope. Yeah, and this HDMI camera then goes to an HDMI to USB interface. It's a small, tiny interface, and then it goes into the computer, and then it goes into the OBS Studio, which is the software that I'm using. Yeah, so essentially, I've got simply an HDMI camera connected to it, and it's a Euromex Nexius Zoom, and yeah, stereo microscope. I'm quite happy with it. Yeah. So let's do that now. Let's have the scope view here again. So, and I'm going to add now some of this solution. I'm going to reduce the magnification here so that we're able to see this a bit better. Okay, so you see the center over here, and I hope yeah, let's go here all the way where that's the edge of the cover glass, which we're barely able to see, and I hope that. Yeah, that's also important. So if you want to add something like a liquid, notice that there's air here, and this line that you see here, this is the border, because over here, down here, we've got liquid, and up here we've got air. And this basically means that I hope that, yeah, as the liquid, the amylase with the enzyme actually approaches, it should actually contact this place here first. Yeah. And then let's see if it's able to digest the starch, or maybe, I don't know, maybe I'm going to go down with the magnification yet further. Yeah, that's now the 4 times. Okay, and yeah, let's give it a try. So I'm going to, and you can actually see on the top what I'm doing, right? Yeah. So. I hope that this actually works. Still air here or not? I'm going to add more. So, and what happens? Nothing. Come on. This is kind of interesting. Let me try again. Because this is a bit frustrating, because today when I tried this, it was really a very nice immediate response, but maybe I didn't get enough of this. Okay. Let's wait until let's see. Ah, it's working. Okay. So you have to watch very carefully. Do you actually see here on the side that where it's starting? Now it starts to work. Do you actually see how here on the edges the black stain starts to disappear? Yeah. This is because the amylase starts to finally, here we go. Yeah. This is because the amylase now starts to digest. Yeah, the starch away. Can you use top illumination flashlight? No, what I'm going to do is the following. Let's see, not top illumination using the compound microscope, but we can try using the stereo microscope. Here we go. Okay, let's zoom in a bit. And here we go. It's a little bit out of focus. Yeah. But you can already see a little bit that it's starting as the liquid starts to work its way inwards. Yeah, on the outside here, where is it here? It starts to it becomes fuzzy as the amylase digests away the starch. So what I think is it's not able to reach it quite well yet because of the I pressed down so much. So let's do the following, like this. And let's see if this kind of speeds up the whole process. And after a couple of minutes, all of the black color should be gone. Let's have a look at maybe at this one over here. Yeah, see, it's starting to become fuzzy on the edges as the amylase starts to break down and digest the starch from the side. Okay. So we're gonna give it a little bit more time. Yeah. What I've also tried is the following, and you don't need a microscope for that. Is you can actually take a little bit of the starch solution, mix it with your own saliva, and as soon as you do that, it will not turn black anymore. Yeah. So the reason is because the amylase in the saliva will also digest it. Yeah. I mean, I've honestly maybe the concentration is not quite as high as it used to be, but this actually used to work quite fast. But let's go down here. You can already see that there is significantly less than before. Yeah. So let's give it maybe a couple of minutes, and then maybe it's going to be completely gone. Yeah. And you can also see that here it's yellow again. This seems to be a little bit where the iodine is released again. Yeah. So this is yeah. So for those of you who just joined in, is the following: those black things that you see here? That is starch mixed with iodine, and then there you have the classical starch reaction happening. But when you add an enzyme to it, like amylase, for example, then the amylase will break down the starch, and the black color is going to slowly disappear again. Okay, thank you. What is this? Ah, yeah. Okay. Yeah, thank you. I got again the questions. Yeah. So maybe I'm just going to add a little bit more of this. You know what? Do you know what I'm going to do now? Is that I'm going to just show you. I'm going to do it a little bit differently. Maybe the effect is going to be a bit stronger when I actually show it to you here directly on the table. Yeah. Let's do the following. I'll take a little bit of iodine. Okay. Then let's take a little bit of the starch again. Okay. Let's remove. Okay, see those? The starch grains, and we're going to now add again some of the dishwashing. I think I have some of the feeling that maybe it's not sufficiently concentrated, so let's add a little bit more of this. Okay, it's the wrong tube. Here it is. So let's mix it. Okay, and let's add some of the enzyme here. mix it a bit. Okay, and let's also wait. Yeah? What's going to happen? Yeah? So it should actually also start to slowly disappear. And as a matter of fact, we can already see this happening right now. That, yeah, it's not quite as dark as it used to be. And then if we wait a few more minutes, then it should actually, what I've actually seen is actually turned completely clear after a couple of minutes. Yeah. So we can also have a look under the microscope here, because after all, this is a microscopy channel. Yeah, here we go. Yeah, you see a lot of the iodine is still present. Yeah, and we're going to add maybe a little bit more of this solution. And let's see if it's able to digest this away. Yeah. So, will you still do a soil sample analysis? Ah, yeah, now you see basically how it's slowly starting to digest it, yeah? Will you still do a soil sample analysis? Okay, I show you what I've organized myself. Okay, not today, but look, this is a so-called a Behrman funnel. Used to do soil analysis. So I'm working on it. Okay, I will also explain to you briefly if you're interested in how this actually works. This is a way how you can collect soil organisms, for example, nematode worms, rotifers, and whatnot. Yeah, yeah. So this is yeah. You see how it's actually starting to slowly break it down. And the one in the compound microscope, I have to add probably a little bit more of this liquid. Just a second, it's not fully broken down yet. Yeah, and here we go. Yeah. So this one actually yes, you see how it actually over here starts to turn bright again from the side. Yeah, somehow the enzyme starts to break down the starch, and then the iodine cannot it does not stain it anymore, because it turns black, because the iodine actually goes into the starch itself, and then it causes this color reaction. Yeah. So you see how how the starch here starts from the outside inwards. Here now you see it nicely. Yeah, from the outside inwards starts to digest the starch. The enzyme starts to digest the starch away. Yeah, and that's why it starts to turn bright from the outside, moving inwards first. Yeah, yeah. So it's actually show here as well. It actually shows how basically what we're visualizing here is a chemical reaction. Yeah. And maybe if I have here in the center, not yet so much. So I probably have to add a little bit more, and then we can. Yeah, but I'm just going to wait a little bit, and then we're able to see, this maybe proceed further. Yeah? So I'm going to now do the following. There is the funnel for nematodes. Okay? So what I'm going to do now is we're just gonna wait with that. I want to slowly. What time is it? Yeah, I'll answer some of the questions that you've got, unless I already answered them. But maybe briefly explain to you what I've planned for the so-called the Behrman funnel. It's not a new concept, obviously, but something that I have not yet tried out, and that's why I would like to try this. Where is the desk? Okay, and I'm just going to show you, because I bought this specifically to do soil analysis. Yeah, this Behrman funnel. I mean, normally you probably can make yourself some kind of a wooden rack or something, but I got myself one of those stands here. These stands are essentially for putting a Bunsen burner here so that you can heat up something here. But I'm using this as a funnel holder, and basically it works like this: that you put here a how do you call this, a sieve or a net in here, so that the soil does not fall through here. And on the bottom side, what you do is on the bottom side is you attach a rubber tube and you pinch it, you clamp it off. Yeah, so that you can basically release the water more easily. And what you do is you put in here, you put soil, and you fill it with water. And the soil, which goes up to here maybe, is filled halfway with water. However, the soil cannot fall through because of either of the filter or of the sieve or the net that you have in here. But any water or any organisms like nematode worms or tiny insects even, this has been used to collect also water bears. When they will touch the water, they will actually fall down the funnel and are collected on the bottom, right? And then you're able to simply take a couple of drops from the water from the bottom, and then you should theoretically have a concentrated collection of soil animals. Yeah. So this is a technique, and I think I've also heard someone who's been working at the university also told me they also sometimes put a very bright light on top because some animals like to avoid light and then they will move downwards. Yeah, and then as soon as they touch the water, then they will basically fall through the sieve, through the net, and are collected here on the bottom. Yeah. So this is I just found my first stentor live right now. Share your pictures. Send me the pictures and then, yeah. So evidently some people are doing microscopy and watching the live stream at the same time. Yeah? And the same thing can not only be used for soil analysis, but you can also put moss in here, for example, with the water bears, and then when the water bears, when they touch the water and let go, then they kind of fall all the way down here. And on the bottom, you have this rubber tube which is clamped off, so you can collect then the sample from the bottom, and then hopefully you have got a concentrated amount of water of soil microorganisms. Yeah. Can you see the Higgs boson under the microscope? That would be quite nice, huh? No, that would subatomic particles are way too small to be observed. Okay, so let's have a look here again. Just a second. Let's check again the scope. Ah, yeah. Look, this is quite nice. You can actually really see how it's starting. The digestion is starting to work its way inwards. I wonder why not over here so much, but maybe it was not able to reach the or it was kind of used up already. But in case you see over here that it's already starting to digest and break down the starch, and then the black color starts to disappear. So. Okay, so what I'm going to do now is I'm just going to have a look at a couple of these questions again. A question to me, is your mini aquarium still alive or you started over? I've got, they are still alive. I've got a couple of jars here where essentially I'm keeping some water fleas and all sorts of things here. So yeah. Sometimes I have to replenish a little bit of water because it evaporates. Yeah, but generally things seem to be fine. Yeah. So, what is the name of the funnel? It's called a Biermann funnel. It's just a regular plastic funnel, right? But the system is called. Let me Google it. How do you spell this? Biermann funnel. I'm just going into Google, and it's actually called Bear. Yes, there is actually a B-A-E-R funnel. Let me copy this into the so it's called a Biermann funnel. I just put it into the chat now. Okay. And if you search for that, then you will see actually also some YouTube videos where they actually use those, because this is the techniques that's used for soil analysis, or one technique at least that can be used for collecting soil organisms. Yeah. Okay. Look, interesting. The Biermann funnel is also used to concentrate parasites for the diagnosis of parasitosis. Interesting. Didn't know that. Okay. Yeah, so that's interesting. Huh? So what I'm going to do now, okay, okay, what time is it? Yeah, we still have a couple of minutes. Let's have a look here what we've got. Okay. Okay. Yeah, gastronomy. Collect seaweed, wash it, dry it, and cut it up. Very good. Salt, spice for food. By the way, concerning seaweed, something that's also quite that I've done is quite interesting is those the seaweed that you have in the Japanese food, the maki, right? Which is those rolls. If you put them under the microscope, it also you can see cells also quite nicely because they're pretty thin. Yeah. As promised last week, I posted a manual about making botanical permanent slides in the Microbehunter forum. Okay. Posted under specimens, samples, and slides. Thank you very much. Okay. So there is in the forum there is a manual now. Okay. Consider changing the double click timing. Yeah, that was because I had a problem with the how do you say the starting of this live stream. Yeah, demonstration effect. Okay, they don't smell. I just tried it myself, and I guess because they're not. The thing is, you got to keep them dry. As soon as they become moist or wet or absorb moisture, then of course there's always the danger that bacteria will start decomposing it, and then it might start to smell bad. Yeah, you need to get more partnerships like that. Ask people. You will be surprised of the response. This was basically in reference to the fact that the company, Globe Scientific, I made a couple of weeks ago, I presented it. They sent me this nice pack of slides, and I just wanted to show you something else here. Another little project that I realized. This is actually for labeling, right? So they put some paint, some matte paint over it. And I was kind of wondering, I've not tried it yet, but I've got a laser engraver. Is it possible maybe to actually engrave something over here using a laser? I don't know. Yeah? But that would be something that I'm also going to experiment. Yeah? So this is nicely for you can use a pencil, for example, for labeling it directly. Yeah, and these are pretty high quality slides here. Yeah? So that's simply something that I wanted to share with you. Could there be anything in these balls that might still be alive? Sure, if maybe there's some kind of cysts or spores, but one would have to actually cultivate them. I think there might be a chance that these Seaballs might contain some bioplastics. Okay, that's most likely in any case the case because you can find them quite in many places. Almost all my insect specimens had in them. You know what I might do? I did this I think last year or so, but I can I've still got the specimens. I've got some artificial meat, so basically some vegan meat as it's called. I've put it preserved it in alcohol, and I've got several tubes of these vegan meat. And if you put it under the microscope, you're going to find a lot of microplastics. It's pretty sad. And the reason is because the vegan meat often contains soybeans, and I think that maybe on the fields on the soybeans with rain and so on, there are lots of I found quite a few plastic fibers. Nile red, I already talked about that. So that Nile red can be used to identify microplastics. I've purchased a rather cheap USB UV LED light used for curing. Yes. Interesting. Works okay. So there are also indeed some UV flashlights. I also have one. One just has to check if the wavelength is correct. Then maybe it's possible to also get the Nile red to shine up. Are there any other ways to hunt Demotex besides sticky tape? I don't know how long. I tried, still nothing. Okay. Yes, there is a technique, and actually I was actually thinking, honestly, it's kind of a coincidence. I was actually thinking about doing also a live stream or a video about this. What you can do is the following. I don't know which way you've been using the sticky tape. So first of all, Demodex are face mites. Okay, and those face mites, they live in the hair follicles. The hair follicles are those, basically parts of the skin that, where the cells that actually make hair, and they like to be, for example, also in the hair follicles of the eyelashes. And if you want to get those Demodex face mites out, you have to do the following. I'm just going to demonstrate this quickly. I don't have sticky tape here, but that it really increases the chance of you finding them. Okay, what you need is you need some tweezers. Okay, so I'm just going to demonstrate this as well, and I've got, where are they? Just a second here. I've got those tweezers here. They're actually also used. You can use those for cover glasses, but they're also used by people who are collecting stamps. Postage stamps, because you don't want to touch the postage. But what you do is and this is a little bit difficult for me to show you. What you have to do is you have to kind of in front of the mirror, you have to grab some of those eyelashes. You have to carefully pull them without ripping them out, and carefully you have to rotate them. I'm not kidding. You really have to do that. This way, because the Demodex face mite, I need some kind of a demonstration here. Let's say that this here is, let's say that this is the hair, right? Let's say that this is the hair that I'm rotating, and this is the hair follicle. And in here, I don't know, in this tube here, let's say this tube here is the face mite, right? It's kind of living in here. And by kind of rotating the hair, you're pushing out the face mite. Okay, this is, so, and then when, so you don't want to rip out the hair, but you kind of want to rotate it like this by pulling on your eyelashes and carefully rotating them. And then what you do is you take some sticky tape and you really press it against the eyelashes closely, and then you're able to, then hopefully they're able to stick on the sticky tape. Okay, so that is, this technique really worked significantly better than simply leaving some tape on your forehead for half an hour and then trying to find it there. Yeah, so this is just a short comment here. Yeah, I'll go through those questions first, and then I'll answer some of the additional questions that came here. Yeah. Could you get a seawater sample? Yeah, I talked about that already. I still have a seawater sample here. I'm living in Central Europe, so I do not have access to marine water. I'm looking at seawater right now. I took it from biofilm and sand with organic matter, different organisms compared to fresh water. Yep. The nice thing about, you might also get different diatoms. Yeah? So very often marine diatoms are circular and have a different shape as well. Yeah. Would you use an inverted microscope? Well, I don't have one, but why not? Or maybe this was in reference maybe to the video with the developing frog. Yeah? When I was 6, I collected frog spawn and watched them develop in a jam jar. Yeah, and the thing is the following. When you do that, I tried this as well a long time ago, and I left the jar standing in the sunlight, and all of the tadpoles died because it was too hot. And when the heat is too high, then there is also too little oxygen. Yeah. Okay. When I was a kid, my dad took me to Epping Forest to collect frog spawn. Okay. Beware that Vanta black is very sensitive to touch, and if you put on varnish, it's pointless. It's glossy again. Just use regular black water paint. Okay. Thank you. Oh, this was here. Yeah, this was in reference to this here because this one is not black enough, so it's still too reflective, as you can see. Yeah, and it would be nice if this were a little bit more black, but Vanta black apparently, as you say here, has the disadvantage that as soon as you touch it, and maybe because if there's grease on it, it will start to become shiny again. Yeah, yeah, and this is basically how it supports the egg. The frog egg is supported, and the first frame of the frog egg looks like a Mars. Here it is. To change the gray background to black background, try stopping down the camera lens to reduce the exposure. Yes, this is something that, basically I have a problem with that. I tried doing this, but my camera this is an HDMI camera, and I unfortunately only have a little bit limited, ability to control that. Yeah, so it does a lot of things automatic, and it was not a very expensive camera. And I can do that, but I'd have to actually do this over the remote control or over the control buttons. But I cannot. I don't have control digitally over the camera, basically from the computer. Yeah. Yeah, the stereo microscope I already mentioned. That's a Euromax Nexius Zoom Evo. You should be able to see the microplastics on the polarized light. Is this correct? Yes, but the thing is, on the polarized light, you're going to see many fibers shine up. Not only microplastics, not even textile fibers and cellulose fibers. And the reason is that those fibers, they depolarize the light. And they will generally shine brightly on a darker background then. So it's not only that microplastics might be polarizing themselves, but actually you see fibers generally under polarized light. Yeah. Does the iodine not interfere with the amylase? Yes, indeed, this is a possibility, and that's also one of the reasons why I washed it a little bit. I don't know for certain about this, but it would not surprise me. Yeah, if this were to take the because enzymes, of course, can be quite sensitive, and yeah, so it's quite well possible. Yeah. But that's why if you remove the iodine again, and if you add a lot of enzyme, then it actually seems to work quite well. Yeah. So top illumination. Yeah, I don't have a flashlight. No, well, that's well. Now I know why my son brought me the flashlight because he read that. Just a second, scope view. So here we go again. So I'm going to turn off everything. This is now a blue light. See, that's too dark. You don't see anything. Yeah, I need a much stronger one, or need to go up with the with the exposure. Yeah, this is actually a UV one, and over here I don't think that we're able to see it as well. Yeah, so let me turn up this here again. You see, that's basically the thing here. So let me quickly see. So some remaining remaining comments. The stentor is so powerful. The whole life on the slide moves when I retract. When he retracts, I was thinking of a bubble burst, but it's him. Here. Thank you very much. Let me do the. Here's a stronger flashlight. I just got a stronger one. Just want to see if it's because I already switched down the exposure so much that. Yeah. Or let's try it with a different microscope here with a. The idea actually is so. But it's just regular light from above. Look! Do you see those funny lines here at the top? It is because the the shutter speed seems to be synchronized with the flashlight somehow. Quite funny, okay? So, in microscopy, you use coarse and fine focus astronomy focuser, okay? Why did this tend to retract? It seems to eat like a rotifer, so retract is not for feeding. Well, I don't know if well, actually, it's Vorticella. What Vorticella do? They retract very rapidly. Stentors essentially look like those trumpet animals. They have basically really like a trumpet. They're going apart. But if the organism is on a thin stalk which quickly retracts, then that's actually Vorticella. Yeah. I add the flashlight to the bottom illumination. Okay. Yeah. Yes. Yeah. So I'm just reading again a couple of comments here. So, Marcel, heating a starch iodine water mix in a burner, the color will turn white transparent. If you then put the test tube in cold water, it will turn dark again. Why is that? That's an interesting one. The thing is the following. I can only guess. I I'd have to try that out, but what I read somewhere, the reason why starch and iodine react and turn black is because the iodine basically places itself into the starch molecule. And maybe, I wonder, if the heat is too high, then maybe the bonds that the iodine makes with the starch maybe breaks, and then maybe you don't have the color anymore. So that could be the reason, but I'm now speculating because the color appears, to my knowledge, please correct me if I'm wrong, because of the bonding that the iodine makes with the starch. Because usually colors are due to the electrons that are bonding, and I can imagine if the temperature is too high, maybe those bonds break, and maybe that's the reason why the starch turns bright again. Yeah, but I'm kind of guessing on that. Yeah. Oops, my stanza is a vorticella. Thank you so much for this correction. Okay. This kind of, how do you say, because you said it quickly retracts, and if it quickly retracts, then it's most likely vorticella. Okay, so let me go back to the desk view here. Okay. So, what time is it now? It's 1 hour 20. Would Seaballs be used as bioindicators? Let's put it this way, I don't know, but the Seaballs themselves actually form because of a physical event, because it's like if you, for example, take string and roll it, then you also get a ball, right? And those balls are essentially produced by wave action, which kind of roll up the seaweed, right? So to what extent it's suitable as a bioindicator, but just for those of you who don't know, bioindicators are usually animals and plants that can be checked to assess water quality. So certain living things like certain types of water quality, and if you find certain animals or microorganisms in certain water, then this tells you something about the water quality. Yeah, if the bacteria high, then probably the organic content is very high, and so on. Right, it's probably more polluted. Because and lower in oxygen concentration. So in certain microbes they need a lot of oxygen again. Yeah. So but I don't know if these how do you say these balls here are actually suitable as bioindicators or not, because they form because of wave action. Yeah. I have an earlier time lapse. Dave Lewis responds again. I have an earlier time lapse of the initial cell division, but a different session a few years back. Can send if interested. Yes, please do send. So if you're if you're actually able to show somehow if the where the cells actually divide, even with a higher magnitude, that would be quite interesting as well. Yeah. So because somebody requested to put it under the microscope again. Where's this? Where did I put the slide? Oh yeah, that is the one with that was the one with the water. Okay, let's see if how this looks like again. And yes, initial cell divisions 2, 4, 8. Yes, please. This would be really nice if you and if you give me the permission again to show it in one of the live streams. I think everyone would be quite happy about that. Yeah. So that is again the because of the request. That's again the thing in water. Okay. Yeah, so. Yeah, by the way, just for your info, just some technical stuff. I'm now using my 4x objective, right? And maybe you're able to see that over here. There is this black. It's in the black circle, right? And if you don't want to see that black circle, then have a look at what. Yeah, I have to remove the condenser. Yeah. So there's this lever that I can flip over. Do you actually see this? Yeah, I can flip it away. Yeah. Yeah, and when I flip it away, then I have to get the full image. And down here I can also remove the prism, and then I get the natural colors here. Again, so this was actually the thing. And where did the? Oh yeah, here it is. Okay, this here is now again with the Uperol. Look, is it starting to slowly brighten up? I don't know. Would be kind of nice. No, not yet. Yeah, we're gonna see whether it actually starts to clear up or not. Alternatively, I could have tried to use vegetable oil, because sometimes vegetable oil also works quite well. But here you see that actually maybe as the mounting medium is starting to work its way in, yeah, it's starting to clear it up because the center is much darker here than the edges. So this is kind of a little bit my hope. Maybe it takes some time for the mounting medium to reach the center, and maybe then the whole thing will become a little bit more clear. That's a little bit my hope. Yeah. Yeah. So yeah, and so that's the one in UPROL. Always remove it again, and in comparison, so water, UPROL, and over here that was the slide that I made before, the dry mounted slide. Yeah, and you have to. So basically, with the sand grains, lots of sand. That's why I've also included the spacer ring. Yeah, and one of the things that I'm a little bit I've been thinking about, and I've mentioned it already a couple. Look, it's again one of those what might be a fish scale, or this cannot be. I don't know if this is the part of a seashell, or but it looks a little bit. It's so thin that this might actually be indeed a scale. Yeah, let's add a little bit of more colors. Yeah. It would be interesting to find out what it could be. So maybe I'm going to check a little bit, and then if I add a little bit of acid, then it starts to dissolve, then it was made of calcium carbonate. Yeah. So I'm just reading some of the questions again here. Yeah. Okay. So yeah, so that's I was just reading some of the comments here. So what I just wanted to say is it would be kind of a nice, interesting citizen science project, a little bit, to maybe actually search for bioplastics and things like this using a microscope. But then it would be kind of also interesting to enter all of this information into a database. Maybe I know, for example, people who are into astronomy. I also used to do a little bit of astronomy several years ago. There are databases. If you discover something interesting, you can type it into a database, and then other people can check on it. And maybe a new asteroid or a new, I don't know, supernova exploding somewhere maybe. But things like this, the citizen science projects for microscopy are not quite as common. So it would be kind of interesting maybe to have a citizen science project maybe for the search of microplastics or certain organisms or whatever. But that is something that would require a little bit of planning. Yeah. iNaturalist, yes, is an app which I also have. And if you don't know it, please do check it out. It's called iNaturalist, and get yourself an account. And there are all the people there who posted pictures of microorganisms. So, and the nice thing is that if you upload a picture into iNaturalist, it will also do an automatic, or it will attempt to do an automatic identification, including microorganisms. Yeah. So this is something that I would like to simply encourage you to try. I've tried it. I've also got an account there. I did not do a lot with iNaturalist, but there are now more and more pictures of microorganisms now also published in iNaturalist. Yeah. So I can recommend it. Yeah. So iNaturalist has a great project related to microorganisms. Yes. I'll check it out again. It's a good. Oh, cool! Look at this. What is this? See, you always discover something interesting. Yeah. So this is a. That's. What? Wow, interesting. This is kind of. I have no idea. Yeah. So yeah, so it could help scientists for new species and biodiversity. Indeed, it's like this that some of the iNaturalist pictures are actually so they call it research grade. So if it is confirmed, you have to also put the place there where you found it, and then it's actually used for biodiversity studies. Yeah. So yeah, a sponge could be. Yeah, maybe part of a sponge. It looks already pretty eroded because it's quite round. Yeah, a micro strawberry. Yeah. So let's add a little bit of color again here. Yeah. Okay. So I think yeah. Very last thing that I just want to show you before I call it a day, because actually it's pretty late at night already. Just to keep you a little bit in the loop, as I used to say. Look at this here. Yeah, yeah. So this is basically, yeah. These are my slime molds. I've now dried the filter paper. Yeah, you can see here. Yeah. So basically, I'm going to try to reactivate them and see if I'm able to grow them back. Yeah, and also over here. It's not so easily visible here. Now in between here, you got a little bit of slime mold, and I've also got a slightly more fresh culture. Yeah. And I've placed some cereals here. So you see that the slime molds are still kind of doing fine. Huh? So maybe last look, I did not check this one yet for a couple of days. So let's see how this one is doing. Yeah, so let's see. Yeah. Yeah, it still seems to be healthy. Just a short time ago I added a new cereal here. They have not found it yet. Yeah. But the slime mold seems to be doing fine. It's a little bit bad in contrast. Yeah. But what we can try is the following. I don't know if this is now this light from the side. Does it? No. The camera acts up a little bit here. Yeah. If you have shining light from the side, you get a slightly better contrast. Yeah. So I can report back slime mold still alive and growing. I started out from a very tiny amount, and now I've got a little bit more of it. Okay. Will you show us the tomato? You know what? This is only a 3-minute thing, and a little bit like last week, I also promised to show you the tomato. So why not here as well? Not the tomato itself, and then I'm going to really call it a day. But I would like to simply try to put a small amount of the fungus under the microscope again. So that sometimes I like it when some of the food becomes spoiled, because then there's something to observe. So a little bit of water. I think it's enough. Then you do the following. You take some tweezers. If I have, here they are. I need my glasses, because I'm already have bad vision. And this fuzzy stuff here, let me see, yeah. Difficult to collect. It's pretty grown in here, but maybe this one works. And yeah, this is not so much. The specimen is not very. Yeah, I was not able to get a lot. Let me try I'm looking for some other tool here. So maybe this is not gonna work. I actually thought that there's gonna be more, but you don't need a lot. But oh, I don't know. I have my doubts. I was actually hoping to be able to collect more here, but let me change to the scope view again. That's a fiber. Let me check the microscope here. Let's go down with the magnification. I think I'm not going to be very successful here. Maybe here is some. Yes, here it is. Here it is. Oh, it's not a lot. So, but typical for fungus. Yeah. Typical for fungus. So, Conidia, yes, beautiful. So this here, I'm going to a little bit of biology, a little bit, just because we're looking at the hyphae of a fungus. I was corrected. I used to say hyphae, and then somebody says no, I'm mispronouncing. It's supposed to be hyphae. But what you see here, these are of course the cells of a fungus. Okay, so that's the so-called the mycelium collectively, and what you see those things here, and occasionally you also find them in water samples. These are the spores, the conidia. Yeah, and so if you see those things here, then they basically they form the spores. Okay, so very very typical for fungus. And I'm just going to I just found this one over here, which is a really nice example. Because this was actually once an examination question that I had to answer a long time ago, when I still was at university. The professor had an examination question: how, if you look under the microscope, how can you actually distinguish bacteria from fungi? Well, first of all, the cells of a fungus are significantly larger. But one of the important characteristics is that when bacterial cells, when they divide, they will not branch off generally. Yeah? But over here in a fungus, it's typical for fungus that they will actually start to branch off. Yeah. So if you see things like this, then you know you're probably dealing with a fungus. Yeah. While bacteria often are in chains and they don't branch off. Yeah. But for fungi, they will actually do that. Yeah. So that's actually one characteristic. Yeah. That and of course the size of the cells is much larger, and then you have those conidia over here, right? And this was actually and over here, this is not a fungus here. There's lots of dirt on the slide. I was not able to get a lot. But I think you get the idea. Okay, so I'm going to call it a day. Let me quickly check again the last comments here. Can you put the whole tomato under the stereo microscope? That's an easy thing, actually. It's kind of very huge. Oh, there seem to be different types of fungi on here. Okay. Yeah. So that's basically how... here you can actually see it also quite well. Okay. Yeah. So it's typical in soil sample fungi, especially from forest soil. Yes. So I'm just reading also some of the comments here, but I think enough for today. I think I'm just going to call it quits again. Today a little bit. Just a couple of things that I just wanted to share with you. And I'm going to call it a day again. Thank you that you joined me. If you have any recommendations, things that you want me to put under the microscope, please feel free to say it. As I already mentioned before, that's kind of a little bit my next project is to get this thing finished. I tell you what the problem was is I could not find a proper tube that I could connect here. That's the only thing why I didn't finish it yet. So that's something that I'm working on right now. I want to wish you all the best, okay? And hope to see you again next week. Happy microbe hunting as always, and bye-bye.